All right, ladies and gentlemen, we're going to be talking about probability. Now, we can go really deep into probability, and I'll talk a little bit more about it in class, but we're just going to cover the basics right now, and then we're going to move on. So, probability, two main types of probability. We have experimental and theoretical. Experimental, if you think about it, experiment makes sense. Experimental, experiment. And what do you do in an experiment? You actually perform an event on something. So in other words, in probability, let's roll a dice. If you roll it 6 times, what's the probability you'll get a 1? Well, theoretical would be 1 out of 6 because we know that there's a 1 and there's 6 chances. Experimental would be me actually rolling it 6 times to see what I actually got. So experimental is actually doing the activity, and theoretical is based on theory. That's why they call it experimental and theoretical. So here's an example. Let me clear all this because I've already written on it. All right. So experimental probability. How you calculate it is the number of times the event actually occurred over the number of trials. So here's my dice right here. Let's say I'm going to roll it 6 times. Out of the 6 times that I rolled it, the first time I rolled a 2, the second time I rolled a 3, third time I rolled a 3, fourth time I rolled a 4, fifth time I rolled a 1, sixth time I rolled a 1. Now I want to know the probability of me actually rolling a 3. So, the number of times it occurs, that's 2, over the total number of trials. Well, there were 6 trials, so that's 2 out of 6, which is 1/3. So the probability of me actually getting a 3 out of 6 rolls would be a 1/3. 1 out of 3 chances. Now theoretical would be this. Number of favorable outcomes, which would be 1, because there's only 1 3 on a dice. And the total possible would be 6, because there's 6 numbers on a dice. This is theoretical, and this is experimental. They're not always the same. And they never will be always the same. But they'll sometimes match up. Here's the theory behind theoretical and experimental. See how I did that? Experimental is actually doing the experiment and recording data. The theory behind that is if I did this activity up here, up here, if I did that activity, experimental probability, 1,000 times, then this number right here will actually be really close to the theoretical. It'll actually start getting there. And we'll work on that in class. Let's go on. Probabilities. Probabilities can be expressed in the form of ratios called odds. So if you ever heard 3 to 1 odds or 4 to 1 odds or 1 to 3 odds, this is what it's talking about. The statement, there's a 3 to 1 chance of rain, is actually using odds. That uses the odd statement. There's a 3 to 1 chance. It's a ratio. So odds in favor, let's look at it first. Let's say I'm rolling a dice. 1, 2, 3, 4, 5, and 6. What's the odds in favor of me rolling a 4? Well, it's the number of... No, I'm sorry, wrong thing. Number of favorable outcomes. So how many 4s are there in a set of dice? There's 1. Right there. 2, the number of unfavorable outcomes. So how many unfavorable outcomes are there? There's 1, 2, 3, 4, 5. So the odds in favor of rolling a 4 would be 1 to 5. Does that make sense? It should. 1 to 5. Let's do odds against. The odds against rolling a 4 is the number of favorable, unfavorable outcomes, which would be 5, and the number of favorable outcomes, which would be 1. It'd be 5 to 1, which is opposite. Wouldn't that make sense? The odds in favor and the odds against be opposite of each other. Oops. Let me show you another example. This one kind of already answers the question for us. It says, suppose you select a ball at random from the golf ball shown at the left. These are golf balls. Don't make fun of them. What are the odds in favor of selecting yellow? Remember, in favor means the number of favorable outcomes first, which is 2 because we're looking for yellow, because there's 2 of them, and then the number of unfavorable, which is 5. So it's 2 to 5 is a favorable outcome. Not favorable outcome, sorry. The odds in favor. Now this one says we want to do the odds against. The odds against would be the number of unfavorable, which would be 5, and the number of favorable, which would be 2. So it's 5 to 2. It's direct opposite of this one. And that's what we're going to be doing in class tomorrow. We're going to be talking about theoretical, we're going to be talking about experimental, and we're going to be talking about odds against and odds for. And I can't wait to see you tomorrow because we're going to start doing some of these probabilities. So that's the end, folks.